Hello and welcome to this session called Architectural Blueprints for the Modern Data Warehouse. And thank you for tuning into this session. Hopefully you all have a good conference so far, and some of you, most of you, maybe also getting out of lunch. So hopefully it was a good lunch also. So first of all, just wanted to thank you to the sponsors. The sponsors pays a bit of the price for this conference and doing the conference at a low price. So please go and visit the sponsors in the lobby area. And my name is Just. I'm from Denmark. As you can see, I'm actually sitting here at my home office in Denmark. I was supposed to come to Wroclaw. It was my plan. I actually had booked the flights, but then unfortunately my daughter got sick and I couldn't stay away for so long. So now I'm here at the home office and hopefully I can do the presentation just as good. I'm a self-employed Microsoft BI consultant, having my own little company with my just me, and then I also have a training company called Orange Man, and I'm a big fan of community work. I've been starting and driving both the Microsoft BI community and the Power BI community here in Denmark, and then my main focus areas in the Microsoft BI stack is on the front end and also on the whole architect side of Asia. I've been building a data warehouse and BI solution in Asia for the last 6 years, so I will say I have a fair amount of experience in that area that I will now in this session present to you. So what is this session about? Yeah, it is about the modern data warehouse. So first of all, we'll just cover what is a modern data warehouse. What is this term before then digging down and looking at different alternatives. This is a session that is a high-level session where we cover different aspects and different ways of building a modern data warehouse in Asia. So I will present for you 3 core ways of doing it, and then some alternative solutions, and also of course comparing the solution, and at the end also looking at some of the price points, because one of the big things in this session is how do we do an affordable modern data warehouse that still can scale. So yeah, 3 core solutions I will present to you, and then 2 variations of these core solutions. First off, if you ask Microsoft, what is the modern data warehouse? If you go to Microsoft website, they have a lot of different architectural blueprints for different solutions you can build in Asia, because yeah, Asia is not just around data and data warehouse. There are so many other aspects, and you can find some reference architectures out there. And Microsoft have this one that is the enterprise data warehouse in Asia, it's called. And if you look at this solution from Microsoft, you see it pretty much looks like something we are used to build in maybe in an on-premise solution, not in a cloud solution, where we have some sources in the one end that could be structured sources or unstructured sources, and then in the other end we present the data in Power BI with Asia Analysis Services, and then we have the components in the middle where we are used to call it ETL solution or the ETL process, but Microsoft has found out some new terms on this and now call it ingest, store, model, serve, prep, and train instead. But it is just basically, it is ETL or ELTL as they also is called. And this solution and these components is fine and valid to do, but Microsoft also maybe have some motive of putting some of these services in here, because if you see the price point for building such a solution is pretty high. This is also taken from the documentation from Microsoft, where I can go in and open up the pricing calculator. And if you open the pricing calculator for the enterprise data warehouse, you will see this bill. It is $2,300 a month to drive a solution like that. And that is because Microsoft have chosen some of the very expensive services to transform and serve your data. You can see Azure Synapse Analytics is here with a very high cost, and also Azure Analysis Services. So this session is really about to show you some alternatives to this one, something that is more affordable and can do the same thing. So we will have a look at that, and I will just take this a drawing from Microsoft and then show it in a little other way. But because we have the data sources in the one end and visualization in the other end, and then we have ETL in the middle. Microsoft call it ingest, store, and here I have, instead of this prep and train and model serve, I just call it transform, because that is what it is. We are transforming the data so we can serve it out to the business users. And here we see that we have, as the transform parts, we have the Spark engine in Azure Synapse Analytics, and also the data warehouse, or SQL pool as it's called nowadays. And then as serve, we have analysis service, and these three components is very expensive. So what are the alternatives to this? There are absolutely some very, very good stuff in this reference architecture. I will say ingest part, where we use Data Factory to do the ingesting, that is very, very common, and something I wouldn't replace with anything else, because that is a solution that's been, when I built my first data warehouse solution in Asia for 6 years ago, I used Data Factory to do the ingesting, and it's just gotten better and better and better ever since that. So that is a core component that I will say we should definitely keep. So what is this Azure Data Factory in Synapse? I call it Azure Data Factory in Synapse. It is a standalone service. You can go in the Azure portal, and that's just fine. Data Factory, but now it's also part of this Synapse Analytics. So you actually have two places where you can start and use this service. I will recommend, if you're starting a new solution, to start up a Synapse workspace and use Data Factory as part of that, because I'm sure that Microsoft will be more committed going forward to put features, new features inside the Synapse version of Data Factory instead of the standalone version of Data Factory, and the price point is the same. So why not just go on and use the latest and greatest version? So I say use Azure Data Factory in Synapse. It is not called actually Azure Data Factory in Synapse. No, it is called Integration Pipelines in Synapse, but it is Data Factory, and this is the service where we can use to ingest data, and there are 80 plus different connectors to different source systems. It could be on-premise source systems like Oracle, it could be REST APIs, it could be a lot of range of systems where we can plug and play and extract the data from these systems in these pipelines. And then Data Factory is also a great service to orchestrate a complete ETL solution, so that we will do it in the right order. First with extract, then transform, then load. So this is also one of the key components of Data Factory. It has the ingest phase and the orchestrate phase. That is the main components, but not for doing transformation in here. So I will certainly say Data Factory is a component we should use in our solution. Then going on back to this drawing, we have on the other side, we have the serve part where Microsoft put in Azure Analysis Services. Azure Analysis Services is analysis services that many of you may know from on-premise, where we also have analysis services part of SQL Server, and this is the Azure part of it. It is a really great and also a de facto way of building and hosting data models. But a couple of years ago, Microsoft actually took a strategic choice and changed in this. And I'm not sure why they haven't reflected this on the official architecture as we are looking at here, because the new direction for Microsoft is not to serve the Power or the analysis service. It is in fact to serving it as part of Power BI, because Power BI has analysis services inside as an engine, and if we do this little shift, we can make it more affordable to host our semantic models. So that is a component I for sure also will keep in my architecture, the data models in Power BI, or our enterprise data models, because Power BI of course also have the self-service data models, but we can combine them if we're hosting, and then we can also make the solution a little more simple, because we will normally anyway have Power BI as our front-end layer, so we can skip one service and not use Azure Analysis Services, just using it. So what is Azure Analysis Services in Power BI? Yeah, as I just told you, it is the Analysis Services engine just inside Power BI. So the Analysis Service engine we know from Azure Analysis Service or SQL Server Analysis Service, where we can build and host semantic data models. And what Microsoft had done in Power BI, yeah, I think it was 3 years ago they announced it, and now we have had it in general availability for at least the last year, is the XMLA endpoint. And the XMLA endpoint means that we can interact and manage and deploy the models directly to Power BI, like we will do it to an ordinary SQL Server or Azure Analysis Services. And we can then develop our models in an efficient way and professional way with Tabular Editor or SQL Server data tool, just that we can then deploy them directly to Power BI with this XMLA endpoint. The XMLA endpoint has a little catch, because for you to be able to open that endpoint, you will need some dedicated capacity, also known as premium capacity. And yeah, we have some different options to get that, and there are two options that are far more cheap than any other options. One of them is what is called Power BI embedded capacity. That's an Azure service that you can spin up and then assign this capacity to one or more workspaces in your Power BI environment. You don't need any tenant administrating access rights to do this. You can do it if you just have being an admin on a workspace. And this means that you can actually opening up you can start buying this service. It takes just a couple of seconds, maybe 30 seconds, to spin up an Power BI embedded capacity, then assign it to the workspace. Then you can use the XMLA endpoint to deploy your data models. Then you can turn off the embedded capacity again, and then only paying for 1 hour of capacity, and then have the XMLA endpoint wherever you need to have it. So it's only when you're deploying your models you need to have it open. And the Power BI embedded capacity, the lowest price point of that one is just $1 for 1 hour. So that's very, very cheap to have the possibility to open up this endpoint. The other options you could do is to use the Power BI Premium per user license, which is a license for $20 a month for one person. And if you just have one person that is deploying the models, then it's just this one person that needs the Power BI Premium per user license. If you go in and do the same trick, we could call it a little hack, where you assign the workspace to the capacity, then deploy the models, and then remove the workspace out of the premium per user capacity again. This way we can use the analysis services in Power BI very, very cheaply, instead of having what people most often think they should have, a premium capacity that has a price point of $5,000 a month. That you don't need that to be able to use the XMLA endpoint if you just use doing this little trick. So this was covering the ingest side and the serve side. I will definitely take these parts out of this enterprise architecture and use these, but what about the store and transform? What are our alternatives? So that's actually what this session is about. What can we put here instead of using a data lake, instead of using a Spark engine, instead of using a SQL pool, a data warehouse pool that is very expensive? Because now we have seen how we can make the serve part lesser expensive when using Power BI with these little hacks. So The first option I wanted to present to you is something I call the traditional modern data warehouse. This was what I presented yesterday in a 4-hour workshop, where we, as part of the 4-hour workshop, made a solution from end to end with labs. So this solution is simply, I will say simply, using a SQL database, an Azure SQL database that you can go in and in the Office Azure portal and then spin off. In this drawing, there are 2 Azure SQL databases, but in fact there are just one. This is just for putting it into this drawing. There's just one SQL database where we ingest our data from our data sources and then do the transformation. So if we focus on to this one SQL database, we can see that underlying inside the database, what I will suggest, and I have made I won't call it a framework, but it's a starting point for you all. I have a GitHub site where you can find this solution. But what we do in this SQL database is that we put it into different layers. So a total ordinary data warehouse solution where you have a layered architecture. You probably use some other namings for your layers, but I call it the first layer for the raw layer. That is just a one-to-one copy from the source system. And then we have the staging layer, which is an intermediate layer where we can do some cleansing of the data. And then we have the baseline layer where we store our dimension and facts in this dimensional model and scheme. So the data, as it travels through these layers, going from the raw state until with all the business rules applied and all the cleansing. And then what actually this solution is doing is that we define our business logic with SQL views, and then we have some generic store procedures that take a SQL view and then will persist it in the next layer. And as part of this GitHub, where I have shared the scripts for you to do a solution like this. It's a very simple way of doing transformation of data, doing it with SQL. And I know a lot of you in the audience are SQL experts and are used to do all your transformation in SQL. So it is just the same as you probably have done before. Maybe some of you have been doing your transformation in integration services or other tools, but this solution is doing it as just in SQL and in some views. And then we have a data mart layer. Data mart layer is not a persisted layer. This is just a view layer. I like to have a view layer, and that's one of my best practices when I'm doing courses, to have a view layer between my data models in my serve part of the architecture and the baseline. That is, you can say, that is the contract between the data warehouse and the data marts, and it's especially handy if you have different developers doing the backend and the front end side of a solution, to have this contract layer in the middle between the baseline data warehouse layer and the data models in the server layer. And then, of course, the last blue arrow is then a refreshing or processing the data models from the data that is exposed in this data mart area. And then in the bottom, we have a layer that is going abroad the other layers, where we can store some logic, logging, ordering data, metadata, some input data, so that we need to have to enrich and do our business logic as part of our transformation. So so this is the transform side. So what is that is the how we will transform the data as part of the modern data warehouse. So let's have a look at that solution actually in and not just doing all slides. So I'll just now I have closed my slides, and then just going in here, showing you my GitHub repository that you can find here, where you can find all the code if you want to do something similar to try out. As I told you, I will only call it a framework because it is mostly a starting point, so you can see the concepts around what you can do with a simple solution like this. And in here, we have some data factory templates, and also the object in the SQL Azure database that is, as you can see, in this different layers architecture with baseline, data mart views, and logging and staging and so on. I have taken this code and deployed it in Azure. I won't go through that process here, just you can have a look at how actually does it look like when it's deployed. So in Azure, I have started what is called a resource group with some different resources in. And in here, we have a database called Modern DB database. And then we also have a Synapse workspace where we can have our ingestion. And then we have a Power BI and also a storage account. We'll come back to that later. So going in and having a look at the database, we have here a query editor as part of this, and here you can actually go in and see that we have some different views in here. We have the first off here this is a very simple dimensional model with just one fact table and then 3 dimensions, and this is our data mart views, data mart layer of it. This is the last layer in the architecture. It is just views that is depending directly on our baseline layer. Then we have some other ones in here. We have 4 different views, and these views are the views that host all our business logic, all our transform and cleansing logic on the data. So and you can see there are 3 of them in the staging layer and 1 in the raw layer. So the principle here is that we take what there are in this view and place it in the next layer. So what is in the raw sales will then be a physical layer in the state sales. What is in the states layer here will be physical tables in the baseline layer. So going in and looking at the tables, we see we have a lot of raw tables that is just tables directly from the source system. In this example, I only have 1 source system, but you could have a lot of different source system that is ingested into this raw layer of the architecture. And then I had down here, as you can see, 1 raw sales that is then being populated to this. So this is how the data is flowing through the different layers in the architecture. So what that's defined in the raw sales becomes the stage sales, and the same you will see with this. So let us have a look at this one, selecting the top 1000 rows. Oh, I will just open a query so you can actually see it here. Here we have here you see the definition of a layer of this view that is called raw sales, and it's very simple. There's not a lot of transformation going on here. I'm just joining 2 different tables and then taking some of the sessions. But in here you could imagine you will do some case, you will do some renaming of some columns, you will do some casting, changing the format, and stuff like that. This is just a very simple example here. And then we have a generic store procedure that will then take this view and then persist it in the table. And the same we have with the stage dim customer, and then going up, putting into our here. So we have some store procedures in here, and let us have a look at them. So we have one store procedure, that is the one store procedure that is generic, that take just one argument. So I can call this store procedure, say, okay, let me update the table states sales, and it will take the view in the raw layer and put it in here. And the same goes for these two, where I have two generic store procedures that I say, okay, update this fact, and you will take what is in the view, put it in the fact table. The same with the dimensions. And then we have four different store procedures that we use to do some generic logging, so that we can see how long did it take to run this update of this fact, how many rows did we process as part of this, and some other stuff, so that we have an audit trail of when we are doing what in here. So let us just open one more query here, just to let you see what there should be doing here. And I have one here, just so you can see that I can call update tables, and then I have two parameters in the store procedures. One that is set to -1, and then one that's set to sale. The reason -1 is that this store procedure is not tend to be called in here. It is called from Data Factory. So this is an ID from Data Factory coming in. But if I just wanted to call it here, I can do that. And let us just go in and execute this one, just so you can see what is happening. Yeah, you can actually see what is happening, but now it is running, and hopefully it will come back and say now it has taken this view, and then it says that okay, it affected 542 rows. And just to be sure, I can go in and I have a logging table where I can see the different task executions that came out of this run, because I have these generic log procedures. And in here we can see, if I just scroll down to the bottom, that this is what was called write down in here. So logging, and then I can see how long did it take, how many rows did I process, and some other things in here that is generic logged. So now we have an idea of how the SQL database works. Now we can go on and then see how will this tie up to Data Factory. So Data Factory, we have a pipeline in here, integration pipeline as it's called, because it's part of Synapse. But in here we call the store procedures in the right order with the right parameters. So we started, we ended, and in the middle we stage the data, we transform the dimension, transform the facts, just so we do it in the right order, transforming the data. And then we also have in here one master package, and this is also one of the advantages of using data or using Azure, because we can call this pipeline in the right order. So actually we start here with scaling up the database, because we can scale it down to save some money. So if we are only doing this as a nightly batch, then maybe the nightly batch takes 3 hours to run. So for the next 21 hours in the day, we will just have it in the lowest tier, and then scale it up now so that it has enough power to transform the data, or first ingest the data and then transfer the data, and then we can scale it down. Actually, what I like here, I can just go in and add this one, and execute a pipeline, because we need one step in here. That is, we need to refresh data model. So, and I have a generic one here. So we will just put that in here. And then actually what you see here is that we have a pipeline that has the extract part, that is the ingest part, then the transform part, and then this is actually the load part, the serving part, where we refresh the data models. And then when we are done, we can end up scaling it all down again, so that we can save some money. So that is the concept around this modern data warehouse, and building a very affordable solution here in Azure with some basic components, and where we can also reuse our competencies if we have already doing transformation in SQL. Yeah, so this was just showing off this solution. Then let us get back to the slides again. And yeah, now hopefully you got an idea of what this concept around the modern traditional data warehouse is all about, and how we transform the data through the raw staging baseline, and then serving the data with the data mart layer in between, and then we can have orchestration in Data Factory also. So the next solution, that is doing the same thing, but just doing it with this data lakehouse approach. So now we don't have a SQL Server. Now we use the Spark engine inside of Synapse, where we have this Spark engine to do the transformation, and then we don't store or serve the data with a SQL database. We do it in the data lake. So let's have a look at these components. This is also a way of doing an affordable solution. So we have the data lake store, where we then ingest and serve our data. And that is the data lake is what is called in Azure and storage account, where we enable this thing called an hierarchical namespace. That way we get a data lake store, and this is unlimited cheap storage. You can have millions and billions and more data in here, and it costs very little. But you can transform data, you can just have data. That is very different from the SQL database, where we could both ingest the data, and also we can and we could store the data and transform the data. Here we can just store the data, but what we can do in a data lake is it is very good to store also semi-structured and unstructured data, where the SQL Server is absolutely best if it is some kind of structure on the data. You need to be able to force it into a table format to store it in a SQL database, where here you can just take the JSON files or XML files or CSV files or whatever files it is, and then store it in here, and then this way you will you don't need to put a schema directly when you read the data or write the data to the data lake. So that is very smart way of doing a data lake in this way. And then we have, after we store the data, we will of course use the Data Factory again to ingest the data, just store it directly in the data lake. Then we can use the Spark engine that you also has part of Synapse. So Apache Spark is not an engine created by Microsoft. Yeah, it is called Apache. It is called and created by Apache. It's an open source engine that is used to do data preparation, data engineering, ETL, machine learning, and it's widely used mostly outside of the Microsoft ecosystem, because it's a very new member of Synapse. You might have heard the company called Databricks, and Databricks is a company that is focusing only on Spark, and also actually one of the biggest contributors to the open source project, but it is open source. So Microsoft has taken this engine and put it inside of Synapse. It is not as mature as the engine is in Databricks, because Databricks is the one that developed most of the engine, so they are always a little step ahead of Microsoft. But still, this is a big focus area for Microsoft in here. And you have the possibility, when you transform the data in here, to transform it with C#, if you like, but maybe you will use PySpark, which is a flavor of Python, to do data transformation. But you can actually also use a flavor of SQL called Spark SQL that is mostly similar to the T-SQL, for SQL Server. So if you have familiar with transforming data with SQL, you can still use the Spark engine. There are of course some terms and some things that you need to know and learn about, especially around how to read and write data directly to a data lake, because that is that's the different part here, because the Spark engine don't host the data itself, or actually it can also host the data, but this is a very expensive solution. So you're probably not hosting data, just doing the transformation and then unloading the data, putting it back into the data lake. That is the most common way of using a Spark, is to take some data from the data lake, transform the data, and then put it back again in the data lake. And preferably you will put it back there in facts and dimension, in a dimensional model schema that you can then build your data models on top of it. And then another big advantage of Spark is that it has a lot of other libraries around AI and machine learning, and you can do graph processing, and you can also use it for streaming. So it's a very mature engine to do data processing in. And if I will look out in the future, maybe 5 or 10 years, I will suspect that a lot of us will be using Spark to do our data preparation and transformation and ETL, because we can reuse our SQL. It is just knowing and learning a new platform to do it based on. But for now, maybe not be your first choice. If you have a strong background in SQL Server, then I will maybe say stick with the traditional modern data warehouse. But if you will go and learn something new, trying to be on cutting edge, trying to be young with the young ones, then Spark is an engine that you will definitely look into. And it is an engine that you pay for when you use it. So you will start it up, transform it into data, and close it down. So you can, it is easily and very easy and affordable to try it out and see if it's something for you. And it can scale really, really well to huge data volumes and handle lots of files and data. So going up to the next and third option. So we covered the traditional modern data warehouse, we covered the Spark engine in Synapse, and now if we go in a maybe completely other direction, this is the more simple solution in Power BI if you wanted to build an affordable solution with Azure. And that is simply using data flows in Power BI. We will still use analysis service to serve our models, but we will use data flows to both ingest and transform our data. And as you can see in this drawing, at the store sign, there is a little data lake. That is because you can actually go in and enable, or by default, all the data you ingest and transform is actually stored in a data lake. So if you're doing the data flow approach, you're actually building a lakehouse. You're just not saying that you're building a lakehouse, but that's actually what you are doing if you're using data flows in Power BI. So what is data flows in Power BI? That is self-service data preparation and ingestion. It is Power Query, if you know that, for Power BI. It is the cloud version of Power Query, and you have access to the same range of sources. That is a lot of sources. Like with the Data Factory, you have a lot of out-of-the-box connectivity to source systems, and then you can do something called linking. So you can link different data flows to each other. So you have something that is doing your ingestion and something you're doing your transformation, and if you link them together, then it means that when you're done with doing your data loading, data ingesting, then it will automatically kick out your transformation of your data, and then handling the orchestration for you. And as I told you, behind this you actually have a data lake, and you will go in a workspace or on the tenant settings, and there you can actually go in and say, okay, I will bring my own data lake, because if you don't do that, as a default, you can't access the files in the data lake. But if you go in and enable and say, oh, instead of using the Microsoft data lake that is hidden from you, you can point it to your own data lake, and there's a big advantage of doing that. That means that you can then access the data from outside of Power BI, so that you can, for instance, go and expose the data to other systems in Azure. So you can, but you can also write the data with other, so you can make it more scalable solution if you do that, and not this very closed solution if you don't do it. So that is, if you want to go this way, I will strongly advise you to go in and enable this bring your own data lake in Power BI. So this was the three different solutions. We unfortunately didn't have time to look at a Spark version and a Power Query or data flow version of it. I only showed you the traditional way, but let us go in and then compare the three different solutions in some different aspects. So we have touched a lot of these things, but let us just move through them. So transformation wise, when you are doing a data transformation, when in a traditional modern data warehouse, you use T-SQL as your language to transform the data. If you're using the data lake house, you have your choice. You can still use T-SQL or Spark SQL as it's called, or you can use Python or PySpark as it's also called here. That's a preference, and you can do some of the operation, some of the transformation. For instance, you can do the cleaning with PySpark and the transforming with T-SQL. That is also possible. Where if you're using the data flows, you don't have any possibility or limited possibility to do it in T-SQL. You will use the built-in language M, or you can just use the GUI, because that is really the advantage of doing Power BI data flows. That is, you have this GUI interface where you can just point and click and make your ingesting and transforming without writing a language. So developer personas, we can say data flow is more for the citizen developer, where both the traditional database, data warehouse, and the data lakehouse is more like a pro developer. That is the big difference here. So portability to other services. So can you take the code you have written in a solution like that and then move it to another provider, for instance, moving it to Amazon or Google, or maybe moving it between different Azure services? Yeah, if you're doing it in T-SQL or doing it PySpark, you can definitely take the code with you and using on other platform or services. But with if you're doing it in M is a language of Power BI, so you're kind of locked in there, and you can't easily, for instance, say, okay, now my solution has grown out of Power BI. Now I wanted to use a more mature engine to transform my data. Yeah, then you sort of have to rewrite it again. So that is not that cool, I will say, for the data flow solution there. And also with the scalability in data volumes, with the lakehouse, yeah, it is unlimited scale. Traditional modern data warehouse, you can scale it. It's still out of the box. 100 or millions of rows, no problem. But if you go up in very, very big data volumes, might not be the best solution. And Power Data Flow, that doesn't scale really well to bigger data volumes. Still, it can take some good volumes, but it just doesn't scale so good. But the big advantage of Power BI Data Flow is that it's actually free. If you already have Power BI, then it's just part of it and can use data flows, where you will, both for the traditional data warehouse, there you will have the SQL database. You can scale it up, scale it down, so it's not that expensive. And the same with the Lakehouse, where you use the Spark engine, that you can scale it up, scale it down, but you can actually also turn it off when you're not using it, so you can keep the monthly cut very low. And then we have the extensibility, where with the Lakehouse you have all these different libraries around machine learning and AI and streaming and graph. So if you need something like that, then might look into building a Lakehouse with Spark. And then data processing, there we have these terms called schema on write or schema on read, where with a Lakehouse, where we read the data from the source system and then write it to the data lake. We don't need to upfront take in and see and fit it into a specific format. We can just take the raw data and then store it in data lake, because that is so good for unstructured and semi-structured data, where if you use Power BI Data Flows and a traditional modern data warehouse or SQL database, then we need to put a schema on the data when we read it. So that really depends on what are your sources. Are your sources mostly just ordinary data that is already in a structured format? Then it might be fine. It's mostly of your data unstructured, then probably the Lakehouse is the best approach. And then if you wanted to use some DevOps functionality, so putting your data under source control and doing some automated deployment and stuff like that, you have good opportunities to do that, both with the SQL database and the data lakehouse, where in Power BI Data Flow it is a solution for the citizen developer. So the DevOps is more for the pro developer. So it kind of makes sense, or at least right now. Microsoft have promised us for a long time that maybe in the future we'll also get some better DevOps possibilities in Power BI, but we don't have them right now. So this was a comparison of the solution. Hopefully it will give you an idea and where and when to use one solution over the other, so you can make a better better decision yourself. So let's have a look here. We have roughly 10 minutes left. So and looking at some variations from the different solutions. So here we have the traditional modern data warehouse, and what if we wanted to support also more unstructured data? What are our possibilities here? Yeah, we have actually the possibility to put in this lake as part of our store layer, so we can both have the SQL database but also a data lake. That is perfectly fine to have some of your data that you will just, if it's structured, put it directly into the SQL database. But if you have some unstructured data, have a lot of that, then you might stand in a situation where you extract a lot of data from the source system, but upfront right now you will only need 10% of it. You extract it all, but then you only put the schema and transformation on the 10%, but you still have the last 90% in your store layer, so you can go back later on. That's the most common case of introducing a data lake in your modern data warehouse architecture. So that is a little variation, so you can support both the structured and unstructured and semi-structured data better with the modern data warehouse. So with the data flows, if we wanted to have this solution more enterprise ready, or combine it with some of the other features of data in the Azure, then I will suggest you to have a look at Data Factory. I started with to say Data Factory is the preferred ingest engine in Azure. So if you have a lot of data you wanted to ingest, then using just data flows it will become very cumbersome because you will make one data flow for each table. You can't do it generic and dynamic, where with Data Factory, you can make it very dynamic when ingesting data from sources. You can actually just make one pipeline, say, okay, give me all tables from this source system, where you have to make one pipeline per each. So if you have a lot of different data, I will suggest you to go and have a look and replace or put in Data Factory in the ingest layer, and with that you will also have the capabilities to use the Data Factory as the orchestration motor for binding your whole ETL flow together. So this was just two different variations of the solutions I presented to you earlier. Then let's have a look here in the end on a pricing estimate. I'm only taking one pricing estimate to you, and that is on the solution I also use the most time talking about, the traditional modern data warehouse. And here you can say this is where we started with the enterprise data warehouse for Microsoft, saying the monthly cost was $2,300 a month. Now you can see it's only $110 here. And of course, you can say that all solution will just be this price. It is very dependent on how much data do you need to transform. That is actually where the most cost is. And as you can see, the SQL database is put here twice, and that is because in my example here, I say, okay, for 3 hours a day or night, I do batch processing. So there I turn it up to a certain level. In this example, I'm turning it up to a level called an S6. This is a pretty big database in terms of memory and CPU, so that we can transform the data there. And then for the rest 21 hours of the day, we turn it down, and it's very cheap to have. So that is where the most cost come into the solution, and it is really depend on how much data do you have, because there's also some cost here for running Data Factory. The cost in here is also just an example that say, okay, I have 90 pipeline activities to run every night, and then doing 30 data movement units, but that's really depending on how much data do you transform and how much data do you ingest out of the sources. But this is just to give you a rough idea that you can actually make a solution that is very cheap in here, around $100. And then we have this Power BI embedded capacity, and that is the capacity I use just to turn it on, to be able to use this XML endpoint that I presented to you earlier, and then turn it off again. And then in this example, I said, okay, we only need to have 10 hours every month where we need to deploy changes to our data models. And yeah, so very cheap solution here. Then we can also extend the solution and put in the Azure Monitor. Azure Monitor is a solution where we can store all our logs from the different services. So this is a service that you will most likely use in all the different architectural blueprints I presented for you, because this is a generic place where you can put in, and then you can set up alerts and analyze your logs for all your different services that you are running in Azure. I will suggest you take a look at that for the monitoring part of your solution in Azure. And then lastly, I have some resources for you. Here's the link where you can go in and find the enterprise warehouse architecture for Microsoft. Then there's a link for my modern data warehouse on GitHub. And then you can also go in and see the pricing estimate. So this actually marks the end of the session, and we have 5 minutes left. So if there's any questions, then please let me know, and I will try and answer them. And other from that, you're also welcome to write to me. There are my contact information is part of the slides, where you can find me on Twitter, or find you're also very welcome to find me on LinkedIn and make a connection and write me questions there if there's anything coming up in this session that was unclear you wanted to know more about. And if there's no questions right now, once again, there's no questions I hear from the audience. Then I hope you have a great rest of the conference. Once again, I'm so sorry I couldn't be in Wroclaw. I have been very looking forward to going and being part of the conference. I really hope I can join you all next year, because it looked like a really cool venue and conference, and a lot of other really great sessions. You can look forward to the rest of the day and also tomorrow. And then there's also, of course, also the party tonight that I will miss. I don't think there's a virtual edition of that one, so I will have a drink at home myself while you go and party. So yeah, you can all have a drink for me. So yeah, and lastly, here are my contact information. If you need to reach out to me, please do so, and I will make sure that these slides is also shared with you afterwards. Yeah, thank you very much for attending this session, and have a great rest of the day.